Welcome pre-cal students to the homework help video. Let me quickly move this up here. I apologize for not having this done. Here we go. And there we go. Okay, welcome pre-cal students to the homework help video. Here's the assignment right here in front of you. So let's go ahead and get started and help you with these homework problems, and hopefully I will be able to answer any questions that you have. On page 143, numbers 1 through 9, the odds, the directions simply say find each of the following if it exists. So let's start with number 1. Notice on number 1 they've given us an f function, they've given us a g function, and they want us to find f plus g of 5. So what we're going to do is we're going to add our two functions together. Now our f function is x squared minus 3. Do you see that right here? And we're going to add to that our g function, which is this right here, 2x plus 1. Okay, there's a positive sign here, so we do not change any of the signs inside the parentheses. There's a positive sign here, so we do not change any of the signs. And then we combine like terms. So x squared plus 2x. And then you have a negative 3 and a positive 1. That would be a negative 2. So there, we have successfully found f plus g of x. Now they want us to put 5 in and evaluate this function at 5. So I have 5 squared plus 2 times 5 minus 2. Everywhere there's an x, I substitute at 5. Well, obviously 5 times 5 is 25. 2 times 5 is 10. Bring down your negative 2, and the answer would be 33 when you combine those numbers correctly. Alright, pretty simple stuff. Let's move on now to number 3. Okay, on number 3 they want us to subtract f minus g. Now when you're adding like the last problem, order really didn't matter. You could have put your f function first or your g function first. When it comes to subtraction, make sure you go in the proper order. It's f minus g. So here's your f function, x squared minus 3. Then of course minus your g function, which is 2x plus 1. Now, out in front of this parentheses, there's a positive sign, so none of your signs change inside the parentheses. Notice there's a negative sign right here outside of this parentheses, so all of your signs will change. A positive 2x is a negative 2x, and a positive 1 is a negative 1. Now let's combine like terms. There's only one x squared term. There's only one x term. A negative 3 and a negative 1 is a negative 4. And now that we've done that, let's go ahead and simplify let's go ahead and substitute negative 1. So we found f minus g, and now let's put a negative 1 in. Be careful, it is a negative 1. Be very careful with your parentheses. Make sure you do things exact, okay? So if you square a negative 1, you do get a positive 1. Negative 2 times negative 1 is a positive 2, and then bring down your negative 4. If you combine those three numbers, you will get a negative 1 for number 3. Okay, let's move on to number 5. Now we're looking at f divided by g. So here's my fraction. Up top I'm going to write f, x squared minus 3, and in my denominator I'm going to write g, 2x plus 1. There, that would be f over g, or in other words f divided by g. Now let me get a drink here. Okay, now a lot of students want to cross off x's like this, take one x away, take one x away, and now hold on, okay? Anytime you have more than one term in the numerator or the denominator, you cannot just start reducing. Now you can factor sometimes and then simplify, but we can't factor x squared minus 3, we cannot factor 2x plus 1, so there's no factoring I can do, there's no more simplifying I can do. So this is f divided by g. Now let's substitute negative 1/2 in. So in the numerator, I substituted negative 1/2 for x, and in the denominator I'm going to substitute negative 1/2 for x. Now, if I simplify correctly, you can use a calculator if you would like to. Negative 1/2 times negative 1/2 is a positive 1/4. A positive 1/4. And a positive 1/4 and a negative 3 would be a negative 2 and 3/4. In your denominator, 2 times negative 1/2 would be negative 1, and negative 1 plus 1 is, ooh, look at this, 0. And you can never have 0 in a denominator. You cannot take this any further. So the answer would be undefined. Okay? There is no solution. It is undefined. You cannot divide a number by 0. In other words, you cannot have 0 in a denominator. Okay, moving on to number 7. We're going to multiply f times g. So here's my f function, x squared minus 3. Here's my g function, 2x plus 1. And now let's multiply. This x squared gets multiplied through the other parentheses. So x squared times 2x is 2x cubed, and x squared times 1 is positive x squared. Now, let's take our negative 3 and let's multiply it through, okay? Negative 3 times 2x is negative 6x. Negative 3 times 1 is negative 3. And now let's combine like terms. Well, you know what? There are no like terms. There's only one x cubed, there's only one x squared, there's only one x, there's only one constant term. So this is not my answer, but that is a successful simplification of f times g. Now they want us to put negative 1/2 in. So 2 parentheses negative 1/2 to the third power plus, then a parentheses, negative 1/2 to the second power, then negative 6 parentheses negative 1/2, and then negative 3. Now let's take this very simply step by step, okay? And let's get a little bit of room to work with here. Alright, here we go. Now let's do our powers first. So a negative times a negative times a negative is negative. 1/2 times 1/2 times 1/2 is 1/8. Bring down your positive sign. Negative 1/2 squared. Well, negative times a negative is positive, and 1/2 times 1/2 is 1/4. So there, I did all of my powers. I simplified my powers. Now, a lot of students say, Mr. Earhart, why did you keep parentheses here after you did the powers? Well, I kept my parentheses here because there was a plus sign on the outside. And I kept my parentheses here because there was a 2 on the outside. So I want to make sure I'm doing this step by step and not leaving anything out. Now I can multiply. A positive 2 times a negative 1/8 is a negative 1/4. And a positive times a positive is a positive 1/4. And a negative times a negative is a positive. 6 times 1/2 is 3, and then negative 3. Well, a negative 1/4 and a positive 1/4 is 0. A negative 3 and a positive 3 is 0. 0 plus 0 is 0. If you combine all of these numbers, you will get 0 for your answer. Okay? Let's move on to number 9. Now earlier in number 3 we did f minus g. Now we're going to do g minus f. So I write my g function first, 2x plus 1, then minus, then parentheses, my f function, x squared minus 3. Now there's a positive sign out front, even though you can't see it. All of these signs stay the same. There's a negative sign in front of this parentheses, so all of these signs change. Your positive x squared becomes a negative x squared. Your negative 3 becomes a positive 3. And now let's combine like terms. Your negative x squared would come first, then your positive 2x comes second, and then you have positive 1 plus 3, that's a positive 4. So there, we very quickly and very easily found g minus f. G minus f, okay? So let's pull this up here real quick. And now let's go ahead and substitute negative 1 in. Now watch carefully how I do this. I bring my negative sign down, then there's an x, so I put parentheses, and then negative 1, then I bring my power of 2 down. Then bring down your positive 2, there's an x, so you put parentheses, negative 1, then bring down your positive 4. Okay, you do your powers first, so bring the negative sign down and put it right here. Negative 1 squared would be a positive 1. And then bring down the rest of your problem. Now, I have a negative outside of a parentheses. A negative times a positive is a negative 1. A positive times a negative is a negative. And bring down your positive 4. Negative 1 and negative 2 is a negative 3, plus 4 more would be 1. So the answer to number 9 is simply 1. All right? Okay, we're doing well. We're just adding, subtracting, multiplying, and dividing different functions. Let's move on now to number 11. Okay, number 11, we're still continuing the same stuff, which is good practice. H minus g. So I'm going to write my h function first, and then minus, and then my g function, which is the square root of x minus 1. Now, there's a positive sign in front of this parenthesis, so x plus 4 stays the same. Now be very careful, there's a negative sign here out in front of this parenthesis. That does not mean you distribute it through the square root and it becomes negative x positive 1. That is totally mathematically non-equivalent. You cannot do that. Now there's a positive sign right here, so a negative times a positive is a negative. Your whole square root is negative. You do not multiply that through the square root. Now, there is just no more simplifying you can do whatsoever. Nothing. Okay, so what you're going to do next is you're going to substitute negative 4 in for x. So here's an x, negative 4, then a positive 4, then a negative sign, then your square root. Here's an x, so negative 4 minus 1. Now, in front of this parentheses, there's a positive sign, so positive and negative gives you a negative 4. Bring down your positive 4, bring down your negative sign. Inside the radical here, we have a negative 4 minus 1, that's a negative 5. And guess what? You can stop right now and put no solution or undefined, whatever you would like to put. And the reason being for that is you can never take the square root of a negative number. Now we've learned before to use the imaginary number I, but in this case they want real answers or nothing at all. So the answer is no solution. Moving on. Number 13, g over h. Okay, g divided by h. I'm going to put my g function up top, and I'm going to put my h function in the denominator. Now there's no simplifying you can do at all to this, so we're going to go ahead and substitute our 1 in. Up top I have the square root of 1 minus 1. In the denominator I have 1 plus 4. Well, let's see if we can't simplify this. 1 minus 1 is 0, so the square root of 0 over 5. 1 plus 4. And of course the square root of 0 is 0, and 0 over 5 is totally legit. You're allowed to have that. You can just never have 0 in the denominator. So 0 over 5 can be solved, and 0 divided by 5 is just 0. So there's your answer, 0. Okay, moving on now to number 15. All right, we have g plus h. So I'm going to write my g function first, x minus 1, close my parentheses, plus, and then my h function, x plus 4. Now, outside of this parentheses, there's a positive sign, so nothing changes inside the parentheses. It's just the square root of x minus 1. And there's a positive sign in front of this parentheses, so nothing changes. It's just positive x, positive 4. And now everywhere there's an x, I'm going to substitute 1. There's really no simplifying you can do here. So I would have 1 minus 1 plus 1 positive 4. Now under the radical, 1 minus 1 is 0. A positive outside of a positive leaves everything alone, so positive 1, positive 4. And now the square root of 0 is 0. 0 plus 1 plus 4 is 5. So the answer to number 15 should be 5. Okay, 5. Now we're going to move on. Let me get a drink here. To 3 problems. Okay, 17, 23, and 29, and they have multiple steps, so do understand that. Okay, so number 17, we're not going to worry about the domain. We're just going to add, subtract, multiply, and do dividing. Okay, so the first thing they want us to do is to add the two functions together, so we'll do that very quickly. Here's 2x plus 3. We've done a lot of these now in your notes, so I'm going to skip some steps here. Okay, We're adding two functions together. This is f plus g. So I have positive signs in front of each parentheses. There we go. And now combine like terms. Negative 3x plus 6. Okay? All right, now the next thing in the directions they ask us to do is subtract f minus g. So here's my f function minus, here's my g function. Now, this group stays the same. This group over here, this negative sign, changes their signs inside the parentheses. And now we combine like terms. 7x plus 0. And of course you do not need to put plus 0, so your answer can be just simply 7x. Alright, moving on now to the next thing they want us to do, which is f times g. So f times g would be 2x plus 3 times 3 minus 5x. Okay, let's take our 2x and multiply it through. We would have 6x minus 10x squared. Now let's take our positive 3 and multiply it through. We would have a positive 9 and a negative 15x. And now we're going to write this in standard form. Your x squared would come first. And then notice I have two x terms here. So a positive 6 and a negative 15 is a negative 9x. And then bring down your constant term, which is a positive 9. Now I'm doing a lot of these very quickly. I'm sure sooner or later I'm going to make a little mistake and not be able to catch it. So if that happens, I apologize and just understand that. And hopefully it won't happen, but the odds are pretty good. Eventually it will. Okay, f times g, and now f times f. So we write the f function, and then we write the f function. Well, 2x times 2x is 4x squared. 3 times 3 would be a positive 9. And then we would have 6x and 6x. So when you combine those, you will get 12x. So there we go. Let me get a drink here real quick and we'll continue on. That was f times f. Next, they want us to do f divided by g. So I simply put my f up top and my g in the denominator. Now you cannot simplify that. There's nothing you can do. Please don't start crossing off the x's and crossing off the 3's. If you have more than one term in the numerator or in the denominator, you cannot do that. Now you can factor sometimes, but there's no way we can factor this. There's no way we can factor this. So we're completely done. Okay, now the next thing they want us to do is take g divided by x. So if they want us to take g divided by x, now the g function simply goes up top and the f function goes in the bottom, and then there's no simplifying you can do. Okay, so pretty simple. Let's move on now to number 23. Number 23. First of all, they want us to add these two together. Okay, now hopefully you remember your square root properties. You have the square root of x minus 3 plus the square root of x plus 3. Now you cannot add those. Let me explain why. If you have the square root of 2 plus the square root of 2, even though you can't see it, there's a 1 on the outside, you would add your outside numbers, which is 2, and you would leave the radical alone. Okay, it's almost like having like terms. If you had x plus x, there's a 1 and a 1. X plus x is, you add the 1's, 2, and you bring down the x. It's really the same thing with radicals. They're like terms. But if you have a 3 right here, a 3, you could not add those two. You could not add those two. I'm not sure why this isn't erasing. Oh well. You could not add those two radicals right there because 1 is a square root of 2 and 1 is a square root of 3. So if this was a plus sign right here, then you could add these. There's a 1 here and a 1 here. So you would have 2 square root of x plus 3. But since the inside of these radicals, they're called radicands, since the radicands are not the same, you cannot add them. So there's nothing you can do with this. You're finished. There's nothing you can do. Okay, now let's go on to the next thing they want us to do, which is to subtract these two. So really, now all they want us to do is subtract f minus g, and again, there's nothing you can do. And if this was a positive sign right here, then you would have 1 minus 1. You would put 0 square root of x plus 3, and of course 0 times anything is just 0. But you cannot do that because the radicands, the inside of the square roots, are not the same, and so there is nothing you can do with this. This is it right here. This is f minus g. Now let's move on to f times g. Now you can multiply unlike radicands. That's totally fine. So we have this group here. Hold on one second. We have f times g. So we have a radical times a radical. Now let me use some easier problems to demonstrate this. If I had 2 square root of 5 times 3 square root of 7, 2 times 3 is 6, and 5 times 7 is 35. That's totally legit. Okay? You multiply the outside numbers and the inside numbers. So we're going to do the same thing here. Of course, on the outside there's a 1 and a 1, so 1 times 1 is 1. I'm not going to worry about that. Now we're going to multiply the insides. Well, x minus 3 times x plus 3, I mean, this really is algebra 2. You should be able to do that very quickly by now, okay? Take your x and multiply it through, take your negative 3 and multiply it through, and then there will be some terms that cancel out. You're left with this right here, x squared minus 9. So there we go. You multiply two radicals together, you multiply the inside, or the radicand, you multiply the radicand here times the radicand here. Now, if this would have been a cubed root, you cannot multiply a square root and a cubed root. Now if it's a cubed root, you can multiply a cubed root times a cubed root, okay? So don't forget all of those algebra 2 properties that you've learned. Okay, moving on, we've done plus, minus, multiply, now f times f. Well, students, can I be honest with you? I mean, we really should know this by now. The square root of 5 times the square root of 5 is 5. The square root of 120 times the square root of 120 is 120. In other words, whenever you multiply the same square root times the same square root, you just get out the radicand. So if they want us to take f times f, there it is. Here's your f function times your f function. And like I just showed you, anytime you take a square root times a square root, you get the inside. So the square root of x minus 3 times the square root of x minus 3 is just x minus 3. Okay? That's f times f. Now they want us to take f divided by g. Now I'm going to go ahead and tell you there's really not going to be a lot you can do here with f divided by g, but that's fine. We'll go ahead and do it. So here's your f function right over here, and this is your g function. Now let's go ahead and get rid of these. We'll just pull them up here for now. Alright, so here's your f function, and that's going to go in the top of your denominator, or of your fraction, excuse me, and here's g. G goes in the denominator, and there we have it. Alright, now if you want to do one thing, you can. I would not take any points off for this. This is totally acceptable, but you could also put this if you wanted to. You could put a big square root and put x minus 3 over x plus 3. Now I did not look in the back of the book and see what their answer is. That's probably what they want you to do, and you should. I would accept either one of those two answers. Okay? And then number 20, the last part, they want us to take g divided by f. G divided by f. So students, I mean, obviously that just means now you put the g function up top and you put the f function in the denominator, and there you go, you're finished. Now again, if you want to put this for your final answer, that is totally equivalent. You're allowed to do that. Either one of those two answers are acceptable. Okay? Alright, let's move on now to one more problem in this section, number 29. This was going to be a lot more challenging, so be ready for that. Okay, we start off with f plus g. So I have 4 over x plus 1 plus 1 over 6 minus x. Okay, let's find a common denominator. Obviously your common denominator is going to be x plus 1, 6 minus x. Now I'm going to take the liberty to cut and paste that so I don't have to write it over and over, okay? So there's your common denominator. So I'm going to write it twice. Remember, when you're adding fractions, you have to get a common denominator. And so now this should all be reviewed to you guys. What do I have extra here I don't have here? 6 minus x, and you bring down your 4. So 4, 6 minus x. Okay? What do I have extra here that I don't have here? X plus 1, and bring down your 1. So 1 x plus 1. Now we're going to put these two fractions together. So I'm going to bring my common denominator right down here. Remember, when you're adding fractions, you do not add the denominator. And now I have, well, 4 times 6 is really 24, and 4 times negative x is negative 4x. So I have 24 minus 4x plus, well, 1 times x is x, and 1 times 1 is 1, plus x plus 1. And now if I simplify the top, of course, I would have this right here. Let's see. I'm going to be a little messy here to save time, but what I would have is, actually I'll try to be a little neat if I can. Yeah, it's not going to work. Okay, we'll just go with the fast method. Negative 4x and x, those are like terms, and that gives us a negative 3x. And then 24 plus 1 would be 25. So there we go. We did it. We found f plus g. Okay? Now, next, they want us to find f minus g. So let's not completely throw, as they say, the baby out with the bathwater here. Let's just stop for a second and see if we can't save us some time. All right? I think that'd be really helpful. So I'm going to try to quickly back everything up here, as you can see. There. Now, really, if it's f minus g, you do understand the only thing that's changed is now I'm subtracting the two fractions. So if I'm subtracting the two fractions, excuse me for a second, would I still not have to get a common denominator? Sure I would. So your common denominator is the same, and you still have a minus sign here. Now be really careful. Okay, and yes, we are still going to distribute this through, so you would still have, hold on one second please, just bear with me for a second. Let me do something here that I think will help you, which I should not have done. I apologize. I'm going to split this problem up a little more than I usually do, because this minus sign can be tricky, okay? I think I've been better off just writing this. Alright, now watch what I'm going to do here, please. Watch carefully. I'm going to go ahead and simplify. 4 times 6 is 24, and 4 times negative x is negative 4x. And now I'm going to simplify. 1 times x is x, and 1 times 1 is 1. Now here's where it gets tricky. Remember, before you were adding these two fractions, and so when you're adding two fractions, I'm not really worried about the sign a whole lot because you're adding, but here, be really careful. You're subtracting this whole numerator, so here's what you have. You have 24, negative 4x, and then because you're subtracting the whole numerator, this positive x, because of this negative sign, the positive x becomes negative, and the positive one becomes negative. This negative changes all of those signs. It really does, okay? And so now, having shown you that, I'm going to go ahead and erase all of this. Hopefully you took notes on it. If you didn't, pause the video and back it up. But now we're going to simplify the numerator. Negative 4x, negative 1x is negative 5x. And then 24 minus 1 would be 23. All over your common denominator, which is right here. All right? And there, wow, I told you these would be a little more difficult, okay? So there, we subtracted two functions. Okay, next they want us to multiply. That's not too bad. So f times g, 4 over x plus 1, this will be easier, times 1 over 6 minus x. Okay? Well, whenever you're multiplying fractions, you do not need a common denominator. Multiply top times top, bottom times bottom. 4 times 1 is 4. And again, this is algebra 2. I'm not going to do all this for you. X plus 1 times 6 minus x would be x times 6, x times x, and then you would take a positive 1 times 6 and a positive 1 times negative x. If you do all of that correctly, you will end up with negative x squared, positive 6 on the end, and then for the middle term you would have, let's see, a positive 6 and a negative 1, so a positive 5x, okay? And I guess you could try to make it look a little sharper by pulling this over to the middle. There we go. All right, so there you go. You multiply two fractions together. Pretty simple. F times G. Now they want us to take F times F, okay? F times F, so we already have one F function written. And now we're going to write it again. So there we go. All right, F times F. 4 times 4 is 16, and x plus 1 times x plus 1 would give you x squared plus 2x plus 1. Pretty simple. There we go. F times F. Excuse me, sorry. Next they want F divided by G. Now, let's be really careful here. Okay, watch this. F divided by G. All right? There's F and there's G. Now watch what I'm going to do here real quick. I'm going to get rid of these things. We don't need these. Let's just throw them up here somewhere. Now F divided by G simply means that I'm going to put my F up top and then put a really big line here, and then I'm going to move my G, which is right here, down to the denominator. At least I was going to try to do that. Let's see if I can successfully do that. There we go. So basically what I have is this over this. But remember, students, what that means, okay? Whenever you have a fraction divided by a fraction, that really just simply means you're going to take the second fraction and flip it. Y'all remember that from middle school? I mean, a fraction divided by a fraction means you leave the first fraction alone, you change this to multiplying, and then you flip the second fraction. So really this 1 should be in the denominator, and this 6 minus x right here should be in the numerator. So there we go. So we flip the fraction and multiply. Now, 4 times 6 minus x, well, it's 4 times 6, that's 4 times negative x. So you would have 24 minus 4x. And then, of course, anything times 1 is just itself, so x plus 1 times 1 is x plus 1. We did it. There's nothing else you can do. I mean, you can't reduce or simplify because you have more than one term in the numerator and the denominator both. So there's not a lot you can do. Now, let's quickly back this up like we like to do. And now let's do this. Next they want us to take, are you ready? Next they want us to take G divided by F. So now I have to very simply put my G function first and then divide my F. So there it is. G divided by F. There it is, pretty simple. So we just did F divided by G, and now we're going to do G divided by F. Now, of course, if you're going to divide fractions, you make it multiplication, and you flip the second fraction. Let's get this bar out of the way for a second, and let's bring this 4 over here, and let's put the x plus 1 up top. And there, we flip the second fraction. Now, 1 times x plus 1 is just x plus 1. And I know you're going to get out just the inverted answer, but I still wanted to show you how this works. And then 6 minus x times 4, 6 times 4, negative x times 4, you get 24 minus 4x. There we go. Just that simple, okay? I hope this is making sense to you guys. It's not meant to be really difficult, okay? Now, here are some problems I never went over in your notes, 36, 37, and 38. And what a great chance for you to learn here and practice, okay? Now, they want us to add f plus g. Very lightly in your book here, you'll see the letter G, okay? Now, what I would do is I would do each problem in your book and then erase it. That's the best way to do this. On a test, I would let you put your answer right here on the graph. maybe with a different colored pen. And so if you'll see, there's a blue G right here in your books, and there's a red F right here. Okay, and so because of that, you should know that the blue line is the G function and the red line is the F function. It's very important. Now on this problem it's not that important because you're doing what? Adding. And when you're adding, it really doesn't matter which one comes first. But in the next problem, we're subtracting. That's going to make a difference, okay? All right, we're taking F plus G. Now watch how we do this. You can only add functions where they're defined. In other words, where the graph actually exists. So please watch carefully what I do here. Whenever you add two functions, remember you're simply adding or combining the x values. Let's go back and look real quick. I'm not sure how much of this I've erased, probably a lot of it. Let's go back to this problem here, number 1 in your homework. When I said take f plus g, notice we took the f part of the x part of f and the x part of g and we added them. So really you're just taking the x values and you're combining them. So what we're going to do is we're going to look for points that are right above each other and we're going to add the x values. Let me show you what I mean. This ordered pair right here is 2, 1. I'm going to write it off to the side. I'm going to circle these 2 points. Okay, this point and this point. One of those points is 2 comma 1 and the other point is 2 comma negative 2, right? Well, you want the y values to match, and when the y values match you can add the x values. Why add them? Because of this right here. If it was subtracting, you would subtract. So when you add these 2 points together, you get 2 comma negative 1. The y value does not change. When you're adding functions or subtracting or multiplying or dividing, you're really just adding, subtracting, multiplying, and dividing the x values. So what we have here is make sure the ordered pairs are right above each other. Like this ordered pair here, this ordered pair right here I'm circling has no ordered pair down below it to go with it, so we ignore that point because remember, if f, the red graph, is not defined over here, we can't add it to that part of G, but we can combine these 2 points. Then what's the new point that I get? 2, negative 1. So with a green marker here, I'm going to go ahead and plot 2, negative 1 right here. Now let's add the next 2 points, this point and this point. All right, so let me get my eraser out, and here we go. We would have what? 3, 5. And the other ordered pair here is 3, 0. So if you add those 2 ordered pairs, the 3 stay the same. 5 plus 0 is 5. So you would get 3 plus 5. So I'm going to go ahead and do this. Go ahead and do that. And my next ordered pair is going to be 3, 5. So right here. All right. Now the next 2 pairs that I see on top of each other would be this one and this one. And that's going to be 6, 5 is the top ordered pair. And the ordered pair below it's going to be 6, 3. So if I add those 2, I will get 6 comma 8. 6 comma 8. So the other pair, the other point that I want to put when I add these 2 together is 6, 6, 7, 8 right up here. There's 6 comma 8. And then lastly, these 2 ordered pairs are right on top of each other, and that would be 9, 4 and 9, 1. So if I add those 2 ordered pairs together, what would I get? 9 comma 5, 9, 5. So let's go ahead and plot that point, 9, 5 over 9 and up 5. So there we go. So you would sketch the line like this. You would start here. My lines won't be perfect, but you go, it should be a straight line. You go to there, then to there, and then to there. And you did it. You graphed, you have a picture. You added f plus g. And I guess I should label the green graph. I should put f plus g. You just added 2 functions using a graph. I think that's really, really cool. Let's try the next one, g minus f. Now here we got to be really careful to put the g point first and the f point second because it's g minus f. G minus f. Okay, so we're going to be really careful. All right, we don't worry about this ordered pair because there's no ordered pair beneath it. We don't worry about this ordered pair because there's no ordered pair beneath it. But I have these 2 ordered pairs right here. Okay, so I have 2, 1. Oh, hold on, I've got to put the, remember, put the G ordered pair first, and G is the red graph. So I'm going to start with G, which would be 2, negative 2. Okay, And then the next would be the f function. So the f function would be 2, 1. Remember, I'm subtracting these two, okay? It's g minus f. So when you subtract these 2 points, you leave the x value alone. Now be careful, watch your signs. And I think this should be a positive one, shouldn't it? Yeah, 2, 1. So you get negative 2 minus 1. Use a calculator if you need to. Negative 2 minus a positive 1, or negative 2 minus 1, that gives you a negative 3. So my first ordered pair that I'm going to plot here is going to be 2, negative 3. Okay? So 2, negative 3. All right, now let's look at these two ordered pairs, this one and this one. Put the red ordered pair first, please. So it's 3, comma 0, and the other ordered pair is 3, 5. Okay. Now, when you subtract these, the x value stays the same. It's 0 minus 5. Well, 0 minus 5 is negative 5. So the ordered pair you're going to put over here is 3, negative 5. So I go over 3. We'll have to move this out of the way a little bit. 3 and then negative 5. 1, 2, 3, 4, 5. So about right here. That's 3, negative 5. So we're doing fine. We subtracted those two ordered pairs. The next two ordered pairs we'll look at will be these two right here. So you write your red first, and your red point is 6, 5. So 6, comma 5. And why did I put the red point first? Because red is G. Have I been doing this backwards the whole entire time, students? I hope not. Wow, how frustrating that is. Let's look at the next number, 38. I think this entire problem, I've been putting the f function first, the red. I was thinking G was red. And I'm really sorry about that. There's no way I'm going to start a whole 45-minute video over. So we're going to really quickly do this. If this is okay with you guys, we're going to grab this right here, G minus F. And we're going to grab this right here, F minus G, and we're going to keep right on going along, because really what we're doing here is F minus G. I feel really bad about that, but there's nothing I can do except restart the whole video. I'm not going to do that. So really what we've been doing here is F minus G. Every time I did this, I believe I put the red point first. I'm pretty sure. Let's see here. Just give me about 2 seconds here, and we will check and make sure. Okay, the red point was 2, negative 2, so we put the red point first there. And then the next point was 3, 0. I put the red point first. Yep. So all the way through here, I've been putting the red point first. And I apologize. I really do. Nothing I can do about that. So we'll continue putting the red point first, 6, 5. And then the blue point would be 6, 3. So if you subtract those, you will get 6, comma 2. 5 minus 3 is 2. So 6, 2, which would be right there. I better erase these points first and then put 6, 2, which would be right here. And then lastly, finally, we have these two ordered pairs here. We're going to put the red first because we're doing F minus G, and the red point would be 9, 4, if I can see that correctly with my aging eyesight. Pretty sure that's 9, 4, and then we have 9, 1. So if you subtract those 2 points, you would have 9, 4 minus 1 is 3, 9, 3. So 9, 3 would be approximately 9, 3 right here. There's 9, 3. So there's the graph that you get. You start here and you would go down and then up and then over. Okay, and that's number 38. I apologize. I feel really bad that I've messed this up, but hopefully you guys can recover. Okay, so that green graph is F minus G. Now let's go to 37, G minus F. Okay, get a little more room here. Slide this over. Let's make this a little bigger so we can see it a little better. And here we go. All right, now we're going to do G minus F, and this time I will do it right. Your G function must come first. So we're not worried about this ordered pair, this ordered pair. They don't have any pairs that line up with them. But these two do. So we're going to put G first, which is the blue point. So I'm going to have 2, comma 1. And then the point beneath it would be 2, negative 2. Okay, so if you subtract those, your x value stays the same. Now watch your sign. 1 minus a negative 2. 1 minus a negative 2 would be 3. So 2, 3. So the proper point would be 2 comma 3. Over 2 and up 3. There's 2, 3. All right, now let's look at these two ordered pairs right here. Of course, G comes first, which is the blue point, which is 3, 5. And then next would be the red point, which would be 3, 0. 3, 0. Okay? And so, if you subtract those, your 3 stays the same, and 5 minus 0 is 5. So 3 comma 5. Okay? So let's go ahead and plot that point, 3 comma 5, which would be right here. All right? And then we have 2 more right here. We're doing G minus F, so we put the blue point first, G, which is 6, 3, and then the F point second, which is 6, 5. So watch your signs. Your x value stays the same, and 3 minus 5 is negative 2. So 6, negative 2 is the point we're going to plot. 6, negative 2. So 6, and then down here to 2. And now we're going to look at these two ordered pairs right here. Well, we're doing G minus F, so your G function is blue. It's going to come first, so that ordered pair is 9 comma 1. And then next is your F function, which would be 9 comma 4. 9 comma 4. So when you subtract these two ordered pairs, your 9 stays 9. 1 minus 4 is negative 3. So there we go. We're going to plot 9, negative 3. All right? 9, negative 3. So over 9 and then down 3 right here. So we start here. We go here, then we go down to here, and then over to here. And that's it. So right here you could label this green graph G minus F. Okay? G minus F. There we go. So that's it. I hope this I hope this homework help video has been a help to you. If you have any questions, don't hesitate to call or email.